This tutorial is for Mobius, Lesson 11A, Homework Question number 3. Solve the following independent system of equations. We have 2x minus 9y equals negative 55 and 8x minus 5y equals negative 3. The interactive textbook showed two options for solving a system of equations, and while they always will work, I find that the second solution or way is a little bit more challenging than a third option that I'm going to give you today as well. But the first thing is we could go ahead and graph these by solving for y to put them in the slope-intercept form. I'm not going to spend the time to do that. And then once you graph them, you find where the two cross. We've done that before, so I'm not going to spend a lot of time. Substitution. This one is the way the interactive textbook shows how to solve this, and it will always work. It's the mathematical way or the algebraic way versus the graphing way. And since this is new, I'll spend some time on it. The last method is called the elimination method, and I actually really prefer this, but you do need to have a little bit memorized, but it's not too bad, and I'll get to that in a minute. So the first thing I'm going to do is walk through the substitution method, and that means that I take any of the variables from any of the equations and solve, and then I substitute it into the other equation. Now that is key, and that is something you have to remember, is that you substitute it in the second equation that you have not solved for, because if you put it back in the same equation, you're going to end up with everything canceling out. So the first thing I'm going to do is just pick, and it doesn't matter. But it does matter that I have two unknowns or two variables, and to solve for two variables I must have two equations. Just a little tidbit, we don't go any further, but if I have three variables I would need three equations, and so on and so forth. And that's how they solve things that end up with, 6 variables. You have to have 6 equations and it gets crazy. But we're only doing 2 and we have 2 equations. That means we can solve it and it won't be too bad. So we're just going to pick, and since 2 is small, I'm going to pick that one just because. It will work no matter which one you pick. So I'm going to take this equation here, and because my handwriting is marvelously beautiful on a computer, I'm going to be just copying and pasting. It might take a little bit longer, but I think we'll be okay. So the first thing I want to do is solve for the x. That means I want it all alone on the left-hand side of the equation, which means I need to get rid of this subtract 9y, which means I need to add 9y to both sides to keep it balanced. And that period just came up because I did some spaces in there. Okay, so this is how I like to keep it. I keep all of my equal signs all lined up so that I know I'm working on this side over here and on this side over here. Adding the 9y, I'm going to draw a little bit and show positive 9y minus a 9y cancels out. And then we're going to go back to here. And so on the left-hand side, I'm only left with 2x, so I'm getting closer to getting x all by itself. 2x, and since I want my equal sign to stay all lined up so I can keep track of everything, I'm going to move this over a little bit. 2x equals negative 55 plus 9 gives me, oh, nope, those can't combine. Negative 55 plus 9y, so I'm going to just do 9y minus 55, or you can put adding a negative 55 because that's actually where the negative is going, is on that one. I find that a lot of students sometimes get the subtraction and the negative kind of mixed up, so I'm going to separate it like this. Even though I know that the subtracting goes to the 55, I think this does help if you're unsure in your algebra. Okay, so now the only thing I have left is to get rid of the 2, and then the x can be all by itself. So to do that, I need to divide this by 2, and just because I'm not going to go ahead and do an equation down here, I'm going to divide it like this. Now on the right-hand side, that means everything is divided by 2, and I could, if I wanted to draw this because it makes it easier just for me, divide by 2 like this. Now if I do that, that means that this and this are both going to be divided by 2, and I can actually separate that out, oops, by going down. One more. We'll do this. Okay, so that means that on the left-hand side, I have 2 divided by 2 is 1. 1 times x is x, so we're just going to have x equals. Now, I am going to separate this out so that it's not just one big fraction. So I get 9, and I'm going to put it 9y over 2. Actually, I'm going to separate it out by hand. I'll draw that in there. You'll just have to suffer with my handwriting. 9y plus a negative 55, and I'm just going to draw this in really quick so that you can see it. This is over 2, and this is over 2. There we go. So now I've actually done exactly what I need, which is solved this for one variable. And so in this method, the substitution, you'll end up with probably dealing with some fractions, which is why it's just not my preferred method. And I'll show you in the elimination method. Okay, so now that I've solved this equation for x, I need to go to the other equation. That is very key. Do not go back to the first one, because it'll just cancel everything out because everything's the exact same. So we're going to go to the second equation here. I'm going to copy and paste this. And we're going to substitute everything that x equals on this side in this equation for x. So I'm going to leave that equation there so that we can see what it is. And where x is, I always put in parentheses to remind myself that everything needs to be included for that x. So inside here, I'm going to have all of this. And I think it actually might be easier to just put it into Word. So I'm going to, or into this equation editor, just for our purposes here. Sorry, this is going to take delete. There we go. And now I need to give it some fractions in here. Sorry about this. Okay, we need to divide by 2 and take this one and also divide by 2. That'll just make it a little easier as I copy and paste things over. Okay, so I'm going to copy this entire thing for x and substitute it into here. And then now I need to finish working on that equation, which is minus 5y equals negative 3. All right, okay, so now that I have to this point, I only have one equation and one unknown, which means I can solve this. For the left-hand side, I need to do the distributive property, which means that 8, and I'm just a visual person, so I'm going to draw that in there. With the distributive, you need to multiply it to every single term. So I'm going to do 8 times 9 halves y, and 8 times 55 over 2. Now, I can multiply those first and then divide, but I actually like doing it a little faster. 8 times this means I have 8 times 9 divided by 2, and since multiplying and dividing can be left to right, and they're kind of on the same step, I can actually divide first and then multiply. 8 divided by 2 is 4. 4 times 9 is 36, and that just makes it a little bit faster. So again, I'm going to do 8 times here. Maybe I should draw that in so that we can see and not miss a step. So I'm going to 8 times both of those gives me, there we go, 8 times, and over here again 8 times, and I know I said I wasn't going to draw, but I am. So here we go. 8 divided by 2 leaves me with, I apologize for all of the handwriting, 4. No, we can't do that. We're gonna undo and type in a 4. There we go. Nope, it's not going to like that either. Okay, just imagine that there's a 4 there. No, I will do this. If you guys can do hard things with learning math, I can do hard things with drawing with a mouse. There we go. Okay. And then over here again, this is going to be a 4. Doing numbers with a mouse. There we go. Okay, so on the left-hand side, we end up with 4 times 9, which is 36. 36, and we still have the y. And then we add 4 times 55. This is 220. And we still have the minus 5y. Now remember, since I've done the division sign, I don't have anything on the bottom anymore because we've taken care of the division. Okay, so that is the left-hand side, and I'm going to move this over so that my equal signs match up. Equals -3. Now I'm going to combine like terms. Since this has a y and this has a y, I can combine those. Since this subtraction is in front of the 5, I can do add a negative so that you remember that, or you can think of it as subtract as long as that negative or subtraction goes with the 5. 36 minus 5 gives me, down here, I'm going to move over since I have less. 36 minus 5 gives me 31y. And I still have the 220 here. And this equals -3. Okay, continuing solving for y, I need to subtract the 220 from both sides. So I'm going to show that here, minus 220, and on the left side, minus 220, which cancels out, except I've just realized I missed my negative sign here. I apologize for that, so we're going to make this a subtraction sign, which means I'm not subtracting. I will be adding 220 to both sides. I apologize for my mistake, but I actually leave those in because I think it's really good for you guys to see as I troubleshoot things. And I always try and check my work as I go so that you understand the same process. And hey, if I can make mistakes, then you can make mistakes, and it's okay. It's not a big deal. You don't have to beat yourself up about it. Okay, so now that I have all of this, on the left-hand side, I am left with just 31y. And on the right side, I have a positive 220 and a -3, which will give me 217. And it's positive. And yes, I'm checking that negative sign in there. Everything looks good. So the only thing I need now is to divide both sides by, and I'm going to draw this in here, divide by 31 so that I can see I have a 31 on the top and the bottom. They cancel. Divide this side by 31 so that I keep it balanced. And then we'll come back into here. On the left-hand side, because 31 divided by 31 is 1, 1 times y is y, or you can think of it as canceling it out. And then 217 divided by 31 gives me 7. There we go. Okay, so now I have part of my answer, and I'm going to actually highlight that so that I remember that's why. Now, the one benefit of this method with the substitution method is that I have a formula solved for x, and all I do is put the 7 into that one, and it's already solved for x. You can go back to any of the originals, and it doesn't matter in this case. Either one, as soon as you put in the y, all you have to do is solve for x. But where I've already done that here, I like to take this one. Just saves me probably 2 steps. So I'm going to come down here, and I'm going to paste it here and solve or substitute the 7 into this. So I'm going to put parentheses around it and then put the 7 inside. And I'm going to go ahead and leave these as improper fractions because then I can combine those. And I end up with 7 times 9, which gives me, I'm going to just show my work here. Okay, 7 times 9 gives me 36, and, or sorry, 63, and then 63 plus a -51, or 55, so I'm going to be subtracting those. 63 minus 55 gives me, sorry, I was looking at my notes that I wrote somewhere, gives me 8. 8 over 2, and then 8 divided by 2 gives me 4, and that's my answer for x. There we go. So we have an independent solution because I have one solution and the ordered pair goes x, y. So the x goes first, 4, 7, and this is independent because there is one solution. And if I were to have graphed these, which I didn't take the time to, these two lines would cross at one point of 4 and 7. Since the video is kind of long, I'm going to show the second method, the elimination method, in part 2.